Now in this next topic we'll see about what the isomerism. Up till now what we have studied about the isomerism there, when two or more compound having the same molecular formula but different in the physical and chemical properties are known as, here, two or more compound having the same molecular formula and differ in the chemical and physical properties, then the phenomenon is called as isomerism, and the such compounds are called as isomers. Up till now what you have studied about the isomerism there, what is this one there, having the same molecular formula but different structural formula there. Now what here what is we are going to study about the physical and chemical properties there, because up till now we have studied only about the structural isomerism. In that case it is quite okay, that definition there, having the same molecular formula but different structural formula there. Now here isomerism is again of two type there. One is structural isomerism, another is stereoisomerism. Structural isomerism that we have studied already there, chain isomerism, position isomerism, then functional isomerism, then metamerism, ring chain. This three isomerism we have studied in the 10th class. Then this three more we will study in this class there, metamerism, ring chain and tautomerism. And in the stereoisomerism there are two kinds of isomerism, geometrical isomerism and optical isomerism, that we'll see in this first time we are going to see about the stereoisomerism there. First we'll look at about the structural isomerism, having the same molecular formula but different in the structure of an molecule, that is called as structural isomerism. Chain isomerism, look at the here example there. When two or more compound having the same molecular formula possess different arrangement in the main chain of the carbon, there the phenomenon is known as chain isomerism. See here example there that we have seen in the 10th class also, what is called as 1-bromobutane there. This is what there, how many carbon, 1 2 3 4, then but will be the root word there, 1 bromo at the first position, bromine will be there, then it is called 1-bromobutane. Molecular formula become what there, C4H9Br. 1 2 3 4 carbon, 3 to 5 5 2 plus 2 7, 7 plus 2 9, 9 H and 1 Br will be there. Similarly with the same molecular formula, what we'll get there, C 1 2 3 4 carbon atom. What is the 1 3 3 plus 6 6 plus 2 8 plus 1 9, H 9 will be there and 1 bromine will be there. Now but what it became there, 1 bromo 2 methyl propane there. It became 1 bromo 2 methyl propane. So now the carbon chain will be of how many, 3 carbon, the longest chain will be made up of what there, 3 carbon atom. So now there will be a change in a chain there, one is of 4 carbon atom, another is of 3 carbon atom. So this kind of isomerism will be called as the chain isomerism there. Next is about what there, positional isomerism. Now positional isomerism, when two or more compound having the same molecular formula but different in their position of the double bond, functional triple bond or the functional group there, then this kind of isomerism will be called as the position isomerism. See here the example of but1-ene, there the position of the double bond will be at the first position, so it is called as but1-ene, the molecular formula C4H8. In the next case it will be what there, but2-ene. Again the molecular formula remains the same but the position of the double bond has been changed to one position to the two position. So in this case it is called as the position isomerism. It can be in the case of functional group also there. Functional group also here in this case of what there, here it is called as propane 1-ol. The alcoholic group will be present at the first position, but here it can be called as propane 2-ol. Now it should be what there, it is another different what we can say, change in the position of the functional group. So this double bond and triple bond will also be referred to as the functional group there. The next kind of isomerism is the functional isomerism. In that case the whole of the functional group had been changed to another functional group there. See here what is the molecular formula there, C2H6O. Here it became what there, C2H6O become what there, ethanol. C2H5OH will be called as ethanol. 1 2 carbon, then how many hydrogen there, 3 to 5 plus 1 6 here, but this will become what there, methoxymethane, and ether has been formed from the same molecular formula. One is alcohol, another is what there, ether. Now all of you know this one, if the functional group changes, the position has been completely the properties had been changed completely over there. So this is called as what is the functional isomerism, in which the whole of the functional group had been changed over there. Now next is what their metamerism. This is the first time that you are going to study about the metamerism. When two or more compound having the same molecular formula and the same functional group possesses different types of alkyl group attached to on the both sides of the compound, such compounds are called as the metamers. Now what we can say, the two or more compound having the same molecular formula but the same functional group, but alkyl groups are different over there. Now look at the here example. What is an example there given over there? Example are given, that is CH3O C2H3 and what is there, CH2 CH3. It can be termed as 1-methoxypropane there. What it is called as 1-methoxypropane. In another case it can be referred to as now look at here, I will show you in this copy over there what this functional group will be called it as. One time it will be here, what is there, CH2O, then again here what is there, here will be what, CH2, then CH2 CH3. Here it can be called as methoxypropane है ना, here methoxypropane. Now if it can be changed like this one, CH3, then bond CH2, then O, then here again CH2, then CH3, then it name will be what there, ethoxyethane. Now in this case what we can say, that here the alkyl group will be here methoxy, here become ethoxy, here became propane, here it became what there, ethane. So when the alkyl groups are changes, then this kind of isomerism will be called as this kind of isomerism is called as which one, metamerism there. Next is about which one there, next is your ring chain isomerism there. Ring chain isomerism. If the same molecular formula, when two compound having the same molecular formula different in the mode of linking of the carbon atom, having an open chain or closed chain structure, and the phenomena is called as ring chain isomerism, and this compound are referred to as ring chain isomers there. Take an example of propene there. Propene is having what there, CH3, then CH double bond, here CH2. Okay na. So this can be referred to as prop1ene or propene there. It can be referred, what should be the molecular formula, how many, C3, H is how many, 3 plus 1 4 plus 2 6, C3H6. Now it can be referred to as CH2 bond, here again what is there, here again CH2, then again bond comes here, then it can be become what there, CH2. It can be referred to as cyclopropane there. Now here it is what it is called prop1ene, here it became what the cyclopropane. So that should be, if one of the compound will form straight chain, another from the same molecular formula a straight chain has been formed, another ringed has been formed, then it is called as ring chain isomerism there. Then finally the last one is what there, finally the last one is our which one there, tautomerism. Tautomerism, what they are telling us, tautomerism may be defined as the phenomena in which a single compound exists in two readily interconvertible form in the relative position of the at least one atomic nucleus, generally hydrogen there. So it can be referred to as what there, tautomerism. Suppose so many compounds are called as ambidient ligands are there, ambidient elements are there which have the two attacking side. They can be attached from the either of the side. Suppose take an example of CN. It can be attached from the either from the C side also and N side also there. If it is attached from the C side, then it is a quite a different scenario. It became what there. If it is attached from the C side, it became what there, cyanide. What they are called as cyanides over there. Okay. Then if it is attached from the N side, then it is termed as what there, isocyanides there. Isocyanides there. Okay. So these are the two different cases there. When it is combined from the C side, that is HCN. If it is HN double bond, then one coordinate bond with C, then it is called as isocyanide. So in that case it can be combined with either from the C side also, then N side also. This kind of isomerism will be called as the what there, tautomerism. Tautomerism is what there, it is an interconvertible form. It can be changed to this ICN, or NC can be changed to one another form also there. So these are the different types of structural isomerism.